76 million years ago, a cataclysmic event almost led to the extinction of all life on Earth. It wasn't an asteroid impact, but what if it had been? Today we are answering the question, could a supervolcanic eruption have killed the dinosaurs? About 76 million years ago, our planet experienced one of the most intense volcanic eruptions in history, unleashing more than 2,000 cubic kilometers of ash, rock, and gas into the atmosphere. This event, known as the Deccan Traps eruptions, not only transformed the landscape of India, but also had profound global implications, including massive climate change and mass extinction. In fact, this event is thought to be one of the two major factors that led to the end of the dinosaurs, with the other being, of course, the asteroid impact. But what if the asteroid hadn't hit? Would the dinosaurs still have gone extinct? And for that matter, would we even exist today if the asteroid had missed? Let's take a look back at the asteroid's impact and see what the science has to say. The late Cretaceous period marked a significant chapter in Earth's history, spanning from about 82 to 66 million years ago. During this time, dinosaurs ruled the land, showcasing a remarkable diversity of forms and adaptations. However, at the end of this era, a catastrophic event occurred that had a devastating impact on life on Earth, leading to the extinction of the dinosaurs and many other species. But before we talk about the asteroid, let's talk about the volcanoes. The Deccan Traps eruptions were a series of massive volcanic eruptions that took place in what is now the Deccan Plateau in India. These eruptions occurred over a period of approximately 30,000 years, beginning around 76 million years ago and ending around 66 million years ago. The cause of these eruptions was the upwelling of magma from deep within the Earth's mantle, likely driven by a combination of factors, including the separation of the Indian subcontinent from Antarctica and the subsequent movement towards Asia. As the magma rose, it created a massive reservoir beneath the Deccan Plateau, eventually leading to the formation of the Deccan Traps, a large igneous province characterized by the outpouring of vast quantities of lava. These eruptions were of an explosive and effusive nature, characterized by the emission of huge volumes of lava flows, ash, and gases into the atmosphere. The total volume of material ejected during the Deccan Traps eruptions is estimated to be in excess of 2,000 cubic kilometers, making them among the largest igneous events in Earth's history. During the eruptions, vast amounts of ash and aerosols were released into the atmosphere, blocking sunlight and disrupting global climate patterns. Additionally, the outpouring of lava resulted in the formation of extensive lava flows covering large areas of the Indian subcontinent. The impact of the Deccan Traps eruptions extended far beyond the immediate vicinity of the eruptions, affecting the global climate and contributing to mass extinctions. The massive release of greenhouse gases such as carbon dioxide led to global warming, while the injection of aerosols into the stratosphere caused a temporary cooling effect. These climatic shifts had profound consequences for ecosystems worldwide, leading to the extinction of numerous plant and animal species. And the timing of these eruptions is critical to their impact on the dinosaurs. Research suggests that the initial phase of the Deccan Traps eruptions began around 76 million years ago, which is well before the asteroid impact that ultimately led to the end of the Cretaceous period. This suggests that the effects of the supervolcanic eruptions played a role in setting the stage for the mass extinction event. However, the intensity and timing of the eruptions varied over time. While the early stages may have had significant impacts on global climate and biodiversity, the later phases could have had different effects. Now let's talk about the asteroid, because the asteroid is one of those rare cosmic objects that has captured the imagination of humans for centuries. Its immense size, destructive power, and potential impact on our planet have inspired awe and fear in equal measure. The asteroid is located in the asteroid belt, a region of space between the orbits of Mars and Jupiter. It is estimated to be about 9.4 million kilometers in diameter, and its composition is primarily rocky with a metallic core. In 1980, the asteroid was officially named after the Roman god of the sky, with the prefix Ida in reference to the mythological Trojan War. This celestial body holds particular significance in scientific research due to its relatively close proximity to Earth and its solid surface. On March 24, 1999, NASA's Near Shoemaker spacecraft successfully rendezvoused with the asteroid and transmitted close-up images revealing its unique characteristics and features. One notable feature is the impact crater named after Galileo Galilei, the Italian astronomer who discovered 4 of Jupiter's largest moons. Another interesting aspect of the asteroid is its rotation period, which was determined through observations of its light curve. Analysis of the light curve revealed that the asteroid rotates on its axis once every 10 hours and 22 minutes. Furthermore, ground-based radar observations have allowed scientists to map the asteroid's surface in 3 dimensions, providing insights into its shape and topography. These studies have revealed that Ida is irregularly shaped with an elongated and porous structure. To date, there have been 5 close approaches between Ida and Earth, occurring in 1929, 1930, 1961, 1991, and 2019. These close encounters provided opportunities for observation and research, allowing scientists to gather valuable data about the asteroid's properties and characteristics. Now, based on the latest scientific evidence, researchers believe that the asteroid that wiped out the dinosaurs made landfall in shallow water, according to a study published last month in the journal AGU Advances. The team used computer models to simulate waves generated by a range of hypothetical asteroid impacts along the Yucatan Peninsula in Mexico. They concluded that an asteroid smashing into shallow water would have generated enormous destructive tsunamis up to 100 meters tall that propagated rapidly toward the Gulf of Mexico and up the American and Mexican coasts. This new study suggests that the waves generated by the Chicxulub impact would have reached Florida within a day and a half and inundated almost the entire eastern coastline of the United States within 2 days. The team's findings have important implications for understanding the far-reaching effects of the asteroid impact that led to the mass extinction event 66 million years ago. Previous research has shown that the asteroid impact triggered massive earthquakes around the world, but the extent of these seismic waves across North America has been less clear. Using a combination of geological and paleontological evidence, researchers have previously estimated the size, speed, and location of the asteroid impact that wiped out the dinosaurs. However, the precise timing and location of the impact remain uncertain. Some studies suggest that the asteroid struck near the island of Bermuda, while others propose a location further south in the Caribbean Sea. Understanding the timing and location of the impact is crucial for comprehending the full extent of its devastating consequences. Okay, so now let's answer the question of the day. Could the supervolcanic eruptions in India have killed the dinosaurs without the asteroid? To answer this question, we need to understand the potential impacts of each of these cataclysmic events on its own. Let's start with the supervolcano. First, let's consider the potential impact of the supervolcanic eruptions on the environment and climate. The Deccan Traps eruptions were massive, releasing enormous amounts of volcanic gases and ash into the atmosphere. This could have led to significant climate change, including global warming and acid rain, which may have negatively affected the health of terrestrial and marine ecosystems. These changes in climate and environment may have put stress on dinosaur populations, potentially leading to a decline in numbers. Additionally, volcanic ash can have long-term effects on soil fertility, impacting plant growth and subsequently affecting herbivorous dinosaurs and the species that relied on them for food. However, it is important to note that the duration of the volcanic activity was relatively long, spanning thousands of years. This may have allowed some dinosaur populations to adapt or migrate to more suitable habitats during the period of intense volcanic activity. While the supervolcanic eruptions alone may have had an impact on dinosaur populations, it is unlikely that they would have led to their complete extinction. Dinosaurs had already faced previous mass extinction events and had shown resilience. Now let's consider the asteroid impact. The impact of an asteroid of the size that is thought to have killed the dinosaurs would have been catastrophic. The energy released from the impact would have been immense, causing widespread devastation in the immediate area of impact. The asteroid's impact would have triggered earthquakes, tsunamis, and wildfires, contributing to a massive loss of life and habitat destruction. Furthermore, the impact would have thrown enormous amounts of dust and debris into the atmosphere, blocking sunlight and leading to a rapid global cooling effect known as impact winter. This sudden climate change would have disrupted ecosystems worldwide, causing mass extinctions and altering the course of evolution. The impact winter caused by the asteroid impact would have had a profound effect on the global climate, triggering a chain of events that ultimately led to the extinction of the dinosaurs. The impact would have thrown vast quantities of dust and debris into the atmosphere, blocking sunlight and disrupting established climate patterns. This sudden reduction in sunlight and the resulting temperature decrease would have created a global ice age within a matter of months. Such drastic climate change would have had a devastating impact on plant life, leading to the cessation of photosynthesis and the collapse of food chains. Herbivorous dinosaurs would have been particularly affected, facing starvation as plants perished and their habitats disappeared. As plant life declined, herbivorous dinosaurs would have struggled to find sufficient food, leading to malnutrition and a decline in their populations. This would have had cascading effects on carnivorous dinosaurs that relied on herbivores as a food source. The asteroid impact triggered massive earthquakes around the world. These earthquakes would have been powerful and widespread, causing extensive damage and habitat destruction. The shaking of the ground would have affected nesting sites and disrupted the life cycles of dinosaurs, further impacting their ability to reproduce and maintain their populations. So what if the asteroid had missed? If the asteroid had missed the Earth, it is likely that the dinosaurs would still have gone extinct because of the supervolcanoes. While the asteroid impact would have been catastrophic in its own right, the supervolcanic eruptions had been slowly weakening the dinosaurs. The long-term effects of climate change, habitat destruction, and ecological disruption caused by the eruptions may have already pushed the dinosaurs to the brink of extinction. In this scenario, the asteroid impact may have served as the final blow, accelerating their extinction and driving the planet into a mass extinction event. However, without the asteroid, it is possible that the extinction process would have been slower, and the dinosaurs might have persisted for a longer period. In conclusion, the extinction of the dinosaurs was a momentous event in Earth's history. While the asteroid impact is often considered the primary cause, the Deccan Traps' supervolcanic eruptions played a significant role. These eruptions, occurring over a prolonged period, unleashed massive amounts of volcanic material and gases, profoundly impacting the global climate and environment. If the asteroid had not struck, the combined effects of the volcanic eruptions and their consequences on climate, habitat, and food availability would have likely still pushed the dinosaurs towards extinction. Though the timeline might have been different, the asteroid's impact served as a catalyst, hastening their demise and driving the planet into a mass extinction event. What do you think? Could the supervolcanoes have killed the dinosaurs without the asteroid, or would we have still existed? Let me know your thoughts in the comments below. Thank you for joining me today. If you enjoyed this episode, please don't forget to leave us a like and subscribe for more updates. Also, make sure to join us on our social media channels where we share even more about dinosaurs and other prehistoric creatures. I'll see you next time.